Every day, entire cities stay alive in the middle of the desert, in places where it barely rains, where there are no visible rivers, and where, in theory, human life shouldn't be able to last for long. Extreme temperatures, dry soil, and a level of water scarcity that anywhere else in the world would make it completely uninhabitable. But something changes that equation entirely. Something you can't see, yet it's working right now, silently, beneath the ground. Long before modern cities, beneath the deserts of Iran, heir to ancient Persia, one of the harshest environments on Earth, engineers were already challenging nature itself. They created a colossal network of underground tunnels called Qanat, capable of capturing water hidden in the mountains and carrying it for miles to lands where, at first glance, life seems impossible. And here's the detail that makes all of this almost unbelievable. This water isn't pushed. It doesn't rely on pumps. It doesn't use electricity. It simply flows, driven only by gravity. Now here's the most impressive part of all. This system wasn't created with modern technology. It wasn't built with machines, and it didn't rely on digital calculations. It was built over 2,500 years ago, and it still works today, supplying entire cities and allowing life to exist where, naturally, it wouldn't. Today, you're going to discover how one of the most intelligent engineering feats ever created by humanity still operates silently beneath the desert, sustaining entire populations to this day, here, on invisible structures. Now, answer me honestly. How did an ancient civilization manage to dig miles of underground tunnels with perfect slope, without any kind of modern technology, and still create a system that works with precision to this day? Because if the slope is wrong, the water doesn't arrive. And without water, these cities simply cease to exist. And what's most intriguing is that, from the surface, you see nothing. No pipes, no visible channels. No sign that life is flowing down there. Just desert. But beneath your feet, there's a constant flow, invisible and vital. If you want to understand how this ancient engineering manages to be more efficient than many modern systems, and why it still sustains entire cities today, subscribe now to Invisible Structures. Because what you're about to see isn't just a historical curiosity. It's a living system. And it all begins in a place where water still exists in abundance. Far from there, in the mountains. It all starts far from the desert. Long before water appears in the cities. Long before any tunnel is dug. The system depends on something completely invisible, hidden deep within the mountains. Aquifers. It all begins far from the desert. Long before water appears in the cities, long before any tunnel is dug. The system depends on something completely invisible, hidden deep within Iran's mountains. Aquifers. These aquifers are true natural underground reservoirs formed over decades and often centuries by the slow infiltration of rainwater and snowmelt from higher elevations. While the surface is scorched by the sun and dries quickly, down below, the water remains protected, stored between layers of rock, sand, and compacted sediments. It's as if an entire river exists, hidden beneath the ground, and that's exactly what the engineers of ancient Persia understood. They realized that trying to find water on the surface, in the middle of the desert, was pointless. The only real solution was to access what was hidden. But here comes an almost impossible question. How do you find underground water? Without sensors, without geological maps, and without any modern technology? The answer lies in something much simpler, and at the same time, incredibly sophisticated. Observation. These engineers analyzed nearly imperceptible patterns in nature, areas where vegetation was slightly denser, subtle variations in soil color, spots where the ground retained moisture longer at dawn, slight temperature differences between nearby points, tiny signals, pointing to something massive hidden underground. Once the ideal location was identified, the most dangerous phase of the entire process began: the excavation of what's known as the mother well. This wasn't just the first hole, it was the exact point where the entire system began. A vertical shaft dug by hand, descending dozens of meters, sometimes more than 50 meters, until it directly reached the aquifer. No machines, no electric lighting, no mechanical ventilation, just workers descending through narrow openings, removing soil layer by layer, in an unstable and extremely dangerous environment. The risks were constant: cave-ins, lack of oxygen, and above all, the risk of missing the target. Because if the shaft didn't reach the aquifer, all the work was lost, and everything had to start over. But when the calculation was right, the result was remarkable. Once the aquifer was reached, the water began to emerge naturally. No artificial pressure, no pumping, no continuous effort. A silent flow began to form, constant, stable, almost eternal. And it's at this moment that the Qanat stops being just an excavation and becomes a living system. But capturing the water is only the beginning, because finding water doesn't solve the desert problem. The real challenge is something else: carrying that water for miles to regions where it simply doesn't exist, without losing volume, without allowing evaporation, and without interrupting the flow at any point. Now imagine the next step: creating a massive underground tunnel with an absolutely perfect slope. If it's too steep, the water speeds up, erodes the soil, and destroys the entire structure. If it's too flat, the water stops. That's it. And even without modern technology, they managed to solve this problem with precision. And this is where Qanat engineering stops being impressive and becomes almost unbelievable. Once the mother well reaches the aquifer, the system finally comes to life. But now comes the greatest challenge of all. Because finding water is only half the problem. The real challenge is making that water travel for miles into the heart of the desert without using any external force. No pumps, no artificial pressure, no energy at all. The only thing that can move this water is gravity. And that demands something incredibly difficult to achieve: a perfect slope, not approximate, not close enough, perfect. From the mother well, builders began digging a horizontal tunnel that slowly advanced toward lower areas where the water would be used. But this tunnel couldn't just run straight at random. It had to descend, almost imperceptibly, a minimal slope, constant and continuous along its entire length. And here's the problem: if the angle was too steep, the water would speed up, increase erosion, and begin destroying the tunnel itself. If it was too flat, the water simply wouldn't move. It would just sit there, and the entire system would fail. Now imagine making that calculation without modern instruments. No lasers, no digital leveling tools, no precise measuring devices. And yet, they did it. And we're not talking about just a few meters. Some Qanats stretch for more than 10, 20, even 50 kilometers across different regions of Iran. All of it with a continuous slope, nearly perfect. So how was that possible? The answer lies in a brilliant solution. During tunnel excavation, multiple vertical shafts were created along the route. These shafts served several purposes. They allowed excavated soil to be removed, improved ventilation, and, most importantly, acted as reference points to maintain the tunnel's correct alignment. From above, these shafts form a chain of circles across the desert, like a dotted line cutting through the landscape. But what really matters is what connects them down below, the tunnel. And that tunnel had to follow an invisible logic, precise and highly disciplined. Builders advanced section by section, adjusting depth based on the intended slope, connecting each segment with extreme care. A small error, just a few centimeters, could compromise entire miles of structure. And even so, they kept the flow working. When the tunnel finally reached lower regions, something remarkable happened. The water began to travel through the entire system on its own. No interruptions, no external effort, no energy cost. A continuous, silent, and steady flow, crossing miles underground until it arrived exactly where it was needed. And here's the most fascinating part. While the desert surface remains dry, hot, and seemingly lifeless, down below, there's an invisible river in motion. An entire system operating in silence and sustaining everything above it. But there's still one detail that makes this system even more efficient than it seems, because transporting the water is only part of the solution. The real secret is how they prevented that water from simply disappearing in the desert's extreme heat. And that changes everything. Transporting water for miles through the desert would already be impressive on its own. But there's an even harsher problem than distance: evaporation. In arid regions, water exposed to the sun can disappear quickly. Extreme heat, dry air, and constant winds cause open channels to lose a huge portion of their volume before the water even reaches its destination. In other words, it's not enough to find water. It's not enough to carry it. You have to protect it along the entire journey. And this is exactly where Qanats become brilliant. Because they don't move water across the surface, they hide it. Instead of letting the flow run under the desert sun, the system keeps everything underground, where temperatures are far more stable. While the surface boils during the day, the interior of the Earth stays cooler. This drastically reduces evaporation and allows water to travel long distances with almost no loss. In practice, a Qanat works like an underground preservation corridor. Water leaves the mountain regions, enters the system, and travels for miles protected from heat, direct sunlight, and the losses that would destroy any open canal. It's a simple yet powerful solution. Instead of fighting the desert, this engineering works around its greatest enemy. But the real impact appears when that water finally emerges. Because at that moment, the Qanat stops being just an impressive structure and becomes part of everyday life. The water that reaches the end of the system is directed into smaller channels, reservoirs, and community use areas. It can flow to crops, supply homes, feed orchards, and sustain small urban settlements. In regions where almost everything around is dry, this water makes green patches possible, permanent crops viable, and entire communities able to exist where, without it, there would be only dust and heat across many parts of Iran. That's when the true scale of the system becomes tangible. This water is used for drinking. It's used for cooking, for washing, for irrigating wheat fields, fruit trees, vegetables, and other crops that provide food and income. In other words, this isn't an abstract flow hidden underground. It's water directly shaping people's daily lives. In many communities, its use must be carefully shared. The Qanats flow is organized among families, properties, or sectors of the community, with defined time slots for each to receive its share. This turns the system into something even greater than simple hydraulic infrastructure. It organizes life. It determines irrigation timing. It shapes agricultural productivity. It sets the rhythm of survival for those who live there. And most impressively, all of this happens without pumps, without electricity, and without constant mechanical operation. Only with gravity, only with slope, only with intelligence. If this level of engineering impresses you, make sure to like the video. Because what you're seeing here isn't just an ancient solution. It's a system that still sustains real lives today. And in the next segment, you'll understand why this invisible technology has endured for centuries without losing its relevance. Now that you understand how this system works, it's impossible to look at these desert regions of Iran the same way. Because Qanats aren't just a clever solution. They are the difference between existing and disappearing. Without this constant flow of water, many of these cities would simply cease to exist. It's not about comfort, it's about survival. We're talking about regions where rainfall is extremely rare, where rivers don't reach, where the surface offers almost no reliable source of water. And yet, millions of people have lived, and still live, in these places. Why? Because there's an invisible system running non-stop beneath the ground. A system created over 2,500 years ago that is still active today, and that's what makes it even more remarkable. While entire civilizations rose and fell, while empires were built and destroyed, while modern technologies became obsolete within decades, Qanats endured, operating without interruption. And there's one detail that makes this even more striking. If this system stops, entire communities collapse, crops disappear, water supply vanishes, and cities that have existed for centuries cease to exist. In other words, it's not just efficient engineering. It's an invisible line that sustains everything. And perhaps the most fascinating part of all is that this system remains almost entirely unseen. You can cross the desert, look around, and notice absolutely nothing. No visible structures, no apparent pipelines, no sign that something extraordinary exists there. But it does. An underground network that can stretch for dozens of miles, connecting distant mountains to entire cities, transporting water in a continuous, silent, and incredibly efficient way. It's the ultimate contrast. A dry desert, sustained by a constant flow of life. The invisible, supporting what matters most. An ancient technology, outperforming modern solutions. And that completely changes how we see engineering. Because maybe innovation isn't just about creating something new. Maybe it's about deeply understanding the problem and solving it in the simplest and most efficient way possible. That's exactly what the creators of Qanats did. They didn't try to dominate nature. They worked with it. They used gravity, respected the terrain, and trusted the natural behavior of water. And with that, they built a system that not only solved a massive problem, but sustained entire civilizations for millennia. Now, let me ask you one last question. How many other invisible structures exist around us, sustaining the world without us even noticing, especially in places like Iran? If this kind of engineering fascinates you, then you're exactly where you need to be. Subscribe now to Invisible Structures, because here you begin to see what truly sustains the world. And tell me in the comments, what was the most impressive part for you? And which city are you watching from? Because, in the end, the greatest works of humanity aren't the ones we see. They're the ones that keep everything running in silence.